Something like that. May not be the same problem, but something like that. Now, my students in the 11:30 session, they said, Professor, first, maybe try to factor that. Well, sometimes in life, this is the way life is. Sometimes things do not work out the way you want them to work out. It will not factor. Will not factor. Then what can you turn to if it does not factor? Quadratic formula. These are all quadratics. We tried quadratic formula on this to get some help. We were desperate. So we tried to plug in those numbers into the quadratic formula and got x to be equal to -2 in this case, plus minus square root. We get a 4. Subtract 4 times 1 times c all over 2. And I did that real quickly. So it's a -2 plus minus square root. Guys, underneath that square root, looks like it's 4 subtract 20. In my case, it's a -16. Is that true? I did it real quickly. I tried it by quadratic formula. You guys who are following me with quadratic formula, I did it quickly, but I think that's it. Okay, it does not factor. And I got a little desperate and I went to quadratic formula. I did quadratic formula, now something's happening. What's happening now? I've got a negative underneath the square root. What's that tell me?
No solution.
There's no solution. Unless you go to imaginary numbers, which we have not done yet. So in terms of real numbers, there's no solution. Here's a way, Professor. I checked, let's say this was a problem in your textbook. It may not be one, but maybe one like this. That, and all of a sudden you flip to the back to check your answers, and they have an answer. And even though I'm trying desperately to try to factor, no factoring, tried quadratic formula, got this nonsense, it says stop. You can't do this. But yet you flip to the back, there might be an answer. Whew! What does one do in math when you run to a case like that? And I think I saw one of these on the UCLA diagnostic test. I told you guys I go to UCLA quite much to use what they're doing. Now, you guys who were with me at 11:30, give me a suggestion.
Well, we tried to graph it.
We tried to graph it. Now, here's the problem. I know, and I think all of my students here know, because of this quadratics will graph into a parabola. All quadratics graph into a parabola, not a straight line. And if that leading coefficient, in my case understood to be a 1, is positive, the parabola is going to open up. So I know right now, yes, it's a parabola. It's going to open up. But where is it? So when I go to a grid, so I get an idea of what that parabola looks like and where is it. All I know at this point is, Professor, it opens up, and that's all I know right now. Now there's lots of places I can make it open up. If I do not graph it precisely, I'm not going to graph the precise graph. Please tell me, is this, if I say, oh, that's it right there, is that opening up?
Yes.
All I know right now is opening up. Is this opening up? Let's put this down here. Is this opening up?
Yes.
Now, can someone, at 11:30, be very singing, can someone in this clever class, tell me, why would I be more apt to accept this one? It's opening up. And not this one, which is also opening up, compared to what you see on board. Go for it.
Because the one on the right is going to cross the x-axis.
The one on the right-hand side, once below, if I extend it, you know these parabolas extend forever. So this means this keeps going like this, Professor. What's going to happen if it extends? It's going to cross the x-axis, and if it crosses the x-axis, guess what you've discovered? The answers to this. That's where the answers are always located on the graph. The answers to any equation are right on the x-axis. So if you have a graph, you can just look at the graph from the x-axis and see where it crosses. Those are the answers, and you need not do any work. Okay, so now, that's true. Now why though, besides that? Why? It opens up, it's going to cross the x-axis, and if it crosses the x-axis, that says I have two answers. I didn't label those for you right here, but two answers. What's wrong with what I've done here though? What did we just discover earlier? There are no answers. I tried by quadratic formula. There are no answers. So I cannot have the parabola opening up, that's the only characteristic I have right now. It's opening up and has no solution. It can't be down here. I don't care if you say, Professor, maybe place it over here. No, the same thing's gonna happen. Extend it. It's going to cross the x-axis again, which means you have answers. We've already said no, there are no answers. So where must I place it so to satisfy what you see up here? It's gotta be above, 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 somewhere above. I don't have the precise graph up here. Does that make sense, guys? It's gotta be above. If it's above there, it's not gonna cross the x-axis, and it should not cross the x-axis because we said there are no answers. Now, can I still say now, you checked the back of the textbook for the answer, you tried your best, now they want to know when is this parabola, this is a parabola here. When is this parabola, look at this guys, this is translating math, reading math. When is this parabola above, greater than, above the x-axis, above 0? Here, 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 here are some choices of where that parabola could be. Are those parabolas always above, guaranteed above the x-axis to satisfy this? Right? So what do you think the answer is? You're going to be shocked to look at the back of the textbook and see the answer. Guess what the answer is? All real numbers. It always works. For some students, you like to use that script R for all real numbers. Negative infinity through positive infinity. Now, I have, I guess, if we're all here today, I've probably got 35 students, which I'm enjoying, 35 students. I don't have the time though. So if I start with Anna, and said, Anna, at random, give me a number to plug in for X, and I'll plug it in and calculate it to see if all this with her replacement is positive. Then I go to my second student, third student, fourth student, go all the way around the room till I get to the student in the back. And they've all given me a different X value to plug in. Guess what this says will happen all the way through all 35 answers. I don't care what X you throw at me. What am I guaranteed?
F of X will always be positive.
The F of X will always be positive. The answer coming out will always be positive. You're saying, Professor, really? Why don't you try a negative number, Professor? Anna may tell you to replace X by 4. She may start you out easy. 4, that's 16 plus 8. What is 16 plus 8? 24? 24 plus 5 is what, 29? Is 29 bigger than 0?
Yes.
So at random, she gave me 4. By the time I get over here, another student says, I'm going to trick him. I'm going to try a negative number. Put a negative 10 in there, Professor. See if it satisfies it. Negative 10. Negative 10 squared is 100. 2 times a negative 10 is what? Negative 20. So you got 100 minus 20, that's 80. 80 plus 5 is 85 greater than 0. You didn't trick me. Then another student, really bright student, maybe sitting in the backpack, and says, oh, Professor, I'll get you. Try 3/4. Try 3/4, start fraction. We'll try one more. We'll try a fraction here. 3/4 is a little bit tougher. 3/4 squared, guys, what? 9 over what? 16? Do that quickly. You square it. 2 times 3/4, I'm doing it in my head here, was 3/2. You can do a little canceling. Plus 5. I don't have to add those up. They're all positive. And I guarantee whatever that is, will they all add up to a positive? Does that satisfy what I want? You give me 3/2, you give me a fraction. It works. Every number's gonna work. And that graph told me it will. It's all real numbers. Now, the 3:30, I don't know why I'm saying 3:30, that's my fall semester. The 11:30 session says, now watch what happens. Now suppose they've said now, when is that parabola less than 0? Which means when is it possible for it to be below? Can't be below. We've already discussed that. So what would the answer now be? No solution. Wow, mathematics. Get ready, guys. Get ready for your adventure when you get started. Mr. Park, I'm still waiting for Yusujan, another student of mine. She sent me an email. She's at Berkeley now. Was it Berkeley she's at? Yeah, Berkeley. She told me she wants to come back and talk to the class, see how Berkeley is. Okay, so I want some of my students who are out there now, and I got quite a few out there. And like I told you, what, Monday, the first day I met you, I have a teacher who's teaching here, I taught her. So I may invite her even to come in one day and talk to you. We're just starting. You are just starting. Yeah. Okay, I'm gonna leave this. Guys, any concerns? And I think there was one like this on the, it may not be the same problem, on one of the handouts. So I'll point that out. Now, me, learning from students, that's what it's all about. How do students realize or look at this? Something else came up that I should do right now, and this is this. Then we'll get started with where I should be. I'd like to sketch, with your help, the graph of this. I'll get some help from you. Here we go. Sketch. You guys, we'll call this a function, which I'll discuss more of today. F of x is equal to, and I'm gonna try this one. Let's hope it works. X cubed, subtract x squared, subtract 2x. Had to do it based on something I heard in the 11:30 session. I'm gonna see a sketch of that. Is this gonna sketch into a parabola? Why? It's a cube, not a square. They all have different shapes. This is a cube function. I like to graph it. Any ideas? Do it again.
Hyperbola.
Oh, no, we're not going to hyperbola. There's something way off. No, something that's going to tie in. You know how I teach. I try to make these concepts connect. Something we did just recently that may at least give you a start, and then I'll do something else that may even help you even out further. Another little idea we've already discussed. Can anyone tell me what you might do that we've already discussed in this class to at least get a start? Factor. Now, in terms of factoring, will this factor? I think it's the common factor of what? X. Here we go. Look at this. If I factor correctly and make no mistake, it looks like that. Now, can I factor further? Yes, it's not factored completely. And those of us who are really strong at factoring, that trinomial will factor into, and watch my factoring here on top of the board, into that. Is that true?
Yeah.
Now, keep in mind, the question was to sketch. I don't have a sketch yet. At least that's a start. I'll give you a little partial credit for that. Now, what are you going to do from there? I got to do the sketch eventually.
How you going to set them to 0?
Those are on the x-axis. So if they want to sketch, if I draw a grid, I know immediately, based on the conversation we're having, that when I solve this, set each one of these equal to 0, which is what I want to do, and this one equal to 0. Guys, you're going to end up, of course, 0 here. You're going to end up with 2, and also what, -1? Those are on my x-axis. So I got 0, I've got -1, I've got 2. I know they're on there. Those are my zeros. Now I notice, let me go ahead, this is not an inequality, guys. So I know these numbers are here. I'll darken them in. Now, may I close my quiz down, turn it in to UCLA and say, that's the graph. Well, I know they're gonna laugh at you. They say, where'd you come from? SMC, who'd you have over there? Don't you mention my name. Mm-mm. You said those 3 points there and say, that's the graph. Now, tell me now another idea, which is recently, which you'll be quizzed on later today, that might help us here.
Find the y-intercept.
Tell me again.
Find the y-intercept.
Okay, I'll do that. In fact, is the y-intercept right now 0? The origin, is the x-intercept also 0? I'm not worried about that y-intercept. This is 0. Something else that we just discussed, I think, yesterday. And it will help me to get the graph. graph is not those 3 points connected. Not a straight line.
Sine analysis?
Do it again.
Sine analysis?
Sine analysis. Now, does anyone remember, you'll have to know by the quiz time, what does sine analysis involve? What does it do? What should I be doing? I need to test the numbers.
That's all the intervals.
There you go. So down here to the left of -1, you get to choose a number. I don't care what you choose. I'm gonna choose -3, but you gotta show me. In between, I'm gonna try -1/2. Be very patient. Here, I'm gonna try 1/2. Here, between, whoa. I could try 1/2. Let's go ahead and try 1. 1's gonna be easier for me. Get guys up here. And out here to the right, I'm gonna try 5. Now, do you guys agree with my setup? Now, those are selected numbers, that's up to you. You don't have to use the same numbers I'm using. Now, what does one do now after that? You go back to your function, and you don't necessarily have to calculate the value. But you're saying, wait, Professor, you want me to put a -3 into, it's best to put it in this factored form, rather than here. You want me to put -3 here, -3 here, -3 here? Yes. I'm not concerned about the number coming out. If I put -3 here, of course, that's negative. But you gotta show me. A -3 subtract 2 in my next factor is -5. Another negative. A -3 plus 1, -2, another negative. So out there, it's a negative times a negative times a negative gives me all together negative. Watch what's gonna happen. You're gonna like this, I think. Now in between, I'm trying -1/2. I'm going back. Replace x by a -1/2. Of course, that's gonna be a negative. Let's see if I can do it here. A -1/2, where am I? -1/2 subtract 2, looks like another negative. And finally, -1/2 plus 1, I think is a positive. What is that all together? Is that a positive? Put it in green up here. That's a positive. Don't be messing up my signs. Now I'm trying a 1. Put a 1 in there for x, of course, that's gonna be a positive. 1 subtract 2, negative. 1 plus 1, positive. Let me step back and look at it, make sure it works out. Is that true, guys? All together is a what? Negative. Finally, out to the right, I'm trying a 5. Put a 5 here, of course, it's +5. Put it here. 5 subtract 2, +3. Sign analysis, 5 plus 1, 6. They're all positive, looks like. Therefore, it is positive. Is that true? Now you said, Professor, how's that going to help me? You think I'm going to get me into Berkeley? You think I'm going to get me into Stanford? How's that going to help? Now, can someone in this clever class tell me, what can I do easily if I know how to read this and get the graph of that function?
Well, you know that it's below,
Oh, tell me again.
you know that it's negative on the.
If it's negative right here, all I know is, he's telling me exactly, he says, Professor, the piece of the graph you're seeking, looking for, because of this, in this interval, it's below the x-axis. It's below. Now what it looks like, I don't know, but I know it's gonna be a curve of some sort. So guys, I'm gonna make mine look something like this. That is below. It's gotta come up and eventually pick up that x-intercept. Let me erase this so you will not confuse that. Is that true? Is that below? Now the next interval, I think we got to be a what? Positive? That's right here. What happens if it's positive, you think? It jumps above. That's where positive is. So you connect here and say, Professor, it's gonna go up. How high up it goes? I don't know, but it's gonna come back down and pick up the next x-intercept. Down here, I tested 1, we got a negative. Now, where is it now? It's back down below. From here to here, it's below. How far down below it works or falls, I don't know, but I do know. Does it eventually have to turn and come back and pick up that? Has to. Eventually it's got to turn, come back, pick up that 2. And then out to the right of 2, I think we got what, positive? What does that say is happening out there? It's above, maybe something like that. And if I ask Mr. Park to use his device over there and graph this, I guarantee you that graph is very similar to what you see right now with the help of sign analysis. There's the graph. Done with the help of sign analysis. That's one big benefit of sign analysis. Does it make sense? Now my lesson coming up today is, please tell me, I've got a lesson coming up. Here we go. Shall I do it right now? Well, I'm gonna do the best I can. As I look at this graph from left to right, goes up, hits a point up here, comes down, hits a point there, comes back up. Up in here, is there a point that might be the highest it goes and it starts to turn and come back down? They give a name for that.
Max.
They call it the maximum. And sometimes people use the word local maximum, sometimes absolute maximum, and I'll tell you the difference. It's a maximum. And then down here, could identify this as a minimum. There might be what they call a local, it might be an absolute, and I'll let you know which is which, but there is definitely a minimum. And then from there, it stretches forever. So that's gonna go through infinity, and this is what dropping down. So that's dropping down through negative infinity. So this piece right here is dropping down forever through negative infinity. This piece is rising, so this piece is falling, this piece is rising. Make sense? Now, before I get into my lesson, which I think this is gonna lead me right into where I need to be. What a benefit. Now, from left to right, let me do this much right here. I'm gonna shade in, right on the graph. What my students have been asking me lots of questions about this. And I'm gonna stop somewhere right in there, guys. I'm gonna say that's the maximum. Please tell me from left to right, is that in the green rising as I move from left to right or falling? The shape portion from left to right, is it rising? Then all of a sudden, when it hits that max, wherever it is, it turns and starts doing this. Until it hits this point down there, which is gonna be a minimum. What's it doing in this area? It's falling. They use the word decreasing. It's decreasing. And then if I pick up and say, hold on, professor, now it hits that minimum down there, wherever that minimum is, we don't know where it is until you reach calculus. Now it starts turning and going back up. And in this region, what's it doing?
Rising.
It's rising. Now, Anna, Mark, they don't have Math 7. They're not in Math 7 yet. You will when you finally get to Math 7. I can't do it with you. The instructor will get mad at me for showing all the secrets. You will eventually be able to find exactly where this is. Where this maximum is, exactly. I can't do it in Math 2. You will be able to find exactly how far down does it drop. Professor, does it drop down to a -10? Does it drop down to a -6? You'll be able to find exactly where that minimum and maximum values are located, but it takes some calculus. And we're not quite there yet, right, Anna? Yeah. Guys, make sense? Now, what's Ramsey done? Ramsey has tied in this that you're going to be quizzed on today, but in a different manner with a graph. I can use sign analysis and get a graph now. That's something crazy. Who on earth would think UCLA would ask you the first day of class to graph this, please, for me? You say, what? Graph? Show the graph of this. And here it is. It's that graph. Guys, any questions there? Yeah. Now, I thought I'd bring that in just to set me up. Here we go. Let's see if I am ready. Yeah, I gotta be very careful on where I am on this. Oh yes. Please remind me, guys, yesterday. didn't I have a student read the definition for a function? And we looked at it, and did we also discuss maybe using a vertical line test to see whether, sure enough, this graph represents a function? Now, since I do have a graph on the board, before I start my work, would this graph pass the vertical line test? Could I draw a vertical line anywhere I wish and be ensured that there's only one point of intersection?
Yes.
That's a function. So I might, before I even erase it, I may say, oh, that's why you use the notation. You can't use that notation unless you know for sure it's going to pass the vertical line test. And it did. So that's why I use f of x. Now, here's what I need to do. I need someone close up here so they can read to me as I put it on the board here. Guys, I'm looking at the side of the paper here that says functions where we were yesterday. We looked at the definition. Now, before I have the student read for me, please tell me this is on the side. Based on what you remember about a function, tell me right quickly, I'm gonna list this. Would you list that? And notice I didn't use the f of x notation. I will if it's a function. Do you think that represents a function? Yes or no?